Hi, welcome to a session on functions. We're going to be looking at the November 2023 NSC paper. That's your finals. So we look at the first question that we have, and the question start off by saying the graphs of f of x is equal to minus half into x minus 1 all squared plus 8. So immediately we see that the parabola is given in square constant form. And if we have the parabola in square constant form, immediately we can pull out the turning point. So if I go to my diagram, but before I go there, let's carry on reading. The next graph that is given there, or the next function that we have is, and I want to highlight that, g of x is equal to d over x, which is our hyperbola. So we have our hyperbola, which is called g, and we have the parabola, which is called f. And then the question goes on to tell us that a point of intersection of f and g is b. So b is our point of intersection, but b is also your turning point. So if it is our turning point, we're going to go to the diagram, and from the equation, we have the f of x equation. We can pull out our turning point to be, from the equation, it's x minus 1. We change the sign to 1, and our y value of our turning point is 8. So we got that directly from the equation. We have x minus 1. You change your sign to a plus 1, and the y value of the turning point is 8. That's our PQ. Then the question goes on to say the graph of f has x-intercepts minus 3, which is shown on the graph, and 5, which is also shown on the graph. And we have a y-intercept, which is sitting at C. So we're ready to take on the first question. 5.1, write down the coordinates of the turning point of f. Now we've already done that, which is sitting on the graph, and we have agreed that the turning point is 1, 8, and then we have our 2 marks. The next question is to calculate the coordinates of C. Now we have mentioned earlier that C is actually your y-intercept, and to find a y-intercept, we let x to be 0. So we have our equation, f of x, and all we're going to do is let x to be 0. So we're going to get y is equal to minus half, where we have an x on the equation. Okay, we have x on the equation. I'm going to change that to 0, minus 1, all squared, plus 8. And you can type that on the calculator, and that will give me 7.5 or 7.5. So the question says find the coordinates of C, and we're going to put that into a coordinate form, which will be 0, 7.5, or 7.5. We go on to the next question, which says us in 5.3, calculate the value of D. So we want to find the value of D. Now the question is, if you look at the graph, there is no D. So we're going to go back to the equation, which says g of x is equal to d over x. So what I want to do in that question is, if g of x is equal to d over x, to find the value of d, all we have to do is sub a point. And if we look at the equation that we have, or the graphs that we have, we see that we have a point called B, which is 1, 8. And all we have to do now is sub this point. G of x refers to y, which is 8, is equal to D. And our x value there is 1. And if we cross multiply, D times 1 is D, 8 by 1 is 8. So we get the value of D to be 8. The next question is to find the range of G. So if we look at the graph and we have G is actually our hyperbola, and if we trace on our y-axis, we will always have a value for y on the graph except at the asymptote. So you'll see at the asymptote, which is y equal to 0, we will not have a point on the graph. So for us to be able to write that down, and the general form is y is an element of reals, comma, y is not equal to the asymptote, and the asymptote here is 0. And that gives me my range for G. Okay, the next question wants us to find out for which values of x is f of x. So we want to know for which values of f is f of x times g of x less than and equal to 0. So we're looking at when is that graph when f of x times g of x is a negative or equal to 0. So to understand this question, very simply put, is for us to get it less than or equal to 0, one graph must be positive, the other graph must be negative, or vice versa. That could be negative and that could be positive. So if we look at the graphs, we are looking at simultaneously when one graph is positive, the other graph is negative. So if we start to trace at the points of intersection, and also looking at the intercepts, so we'll notice that this hyperbola is below the x-axis, so it means this graph here is negative. So if the hyperbola is negative there, we need to find out when is the parabola positive while the hyperbola is negative. And if we look on the top, that's where the graph is positive. So we have our first answer, which will run from -3 to 0. You will notice that the parabola is positive and the hyperbola is negative, and that will give us positive times a negative is a negative. So there's our first answer that we want to write down. And to write that down, it's very simply in notation form is x is an element, and we're starting at -3 and we're ending at 0. Now we will include -3 because at -3 the parabola is 0 and anything times 0 is 0. But we will not include 0 because at 0 we have an asymptote for the hyperbola. You'll notice that this is your asymptote for the hyperbola. So that's our first answer when it is positive times negative, giving your answer less than or equal to 0. The other solution is if we look at the graphs again, we're looking at the graph. You'll notice that from 5, the parabola is negative. But if you look above the x-axis, the g graph, which is the hyperbola, is positive. So there's your other solution. So the other solution is actually running from 5 going on to infinity. And to write that answer down, it's simply we could say x is an element starting at 5. We're going to include 5 because at 5 the parabola is 0, and we're going to go on to infinity. And we cannot include infinity because nobody knows where's infinity. Now another way to write the solution in set builder notation would be x less than 0 but greater than or equal to 3, or in this case we could say x greater than equal to 5. So there are your two solutions for 5.5. Okay, I'm going to go on to 5.6. I just want to erase my board so I can work on the next question. Clear our graph as well. And the next question wants us to find out, calculate the values of k so that h of x of minus 2x plus k will not intersect the graph of g. Okay, for 5.6, what we want to do is, it says, when will this graph not intersect? So we know normally for points of intersections, we equate both the equations. So we're going to take the h and equate it to g. And h is minus 2x plus k is equal to, and the g of x is equal to d over x. And what we're going to do here is find an LCD, which will be x, and we're going to multiply to get our LCD going. We multiply the first term by x, second term by x, and if we look at the last one, d over x, the denominator is x. And then we're going to carry on working. That will give us minus 2x squared plus kx is actually equal to d. And we're going to take everything on one side, which minus 2x squared plus kx minus d is equal to 0. And what we're going to do now, we have found out d, and remember d in our previous question was 8, so we can replace our d with minus 2x squared plus kx minus 8 is equal to 0. And then we're going to find delta, and we're going to use nature of roots. So remember, delta is equal to b squared minus 4ac. And in working out the discriminant, delta, we would get, and I just want to put down the values before we go on. Our a value is minus 2, our b value is k, and our c value is minus 8. We're going to substitute that, and we will get b squared, which will be k squared, minus 4, the a value is minus 2, and your c value is minus 8. And that gives us delta to be k squared minus 8 by 8 is 64. Now, we are looking at a solution where they do not intersect. So we're looking for roots that are not real. And that is when delta is actually less than 0. So we're going to be looking at when is k squared minus 64 less than 0. And if we solve that, we get the critical values here to be 8 and minus 8. Okay, if we actually look at that on a parabola, k squared minus 4, and quickly get a picture of that, and you would see the parabola will be looking, and with your CVs being at minus 8 and 8. And we're looking at when is it less than 0, negative, and that will run from minus 8 to 8. And that gives us k would be less than 8 but greater than minus 8. And that's when they will have non-real roots, or we could say they will not intersect.